Now the ugly one, I bring down negative 1/2 and I subtract 1 from negative 1/2. Okay. Now I have to play with this. I have to see what's happening here before I even plug in again. So I have limit as x approaches 0 from the right. So I have a -2 because it's a fraction. Leave it alone or put it in front. So then we have 1 over x. And this is 1 over x to 3/2. So I have to flip it. X to 3/2. Okay, we're getting close, quite close. I'll put the negative outside. So I have the limit as x approaches 0 from the right, x to 3/2 minus 1. Because x to 3/2 is in a numerator, and from the power of the numerator, I subtract the power of the denominator, and I have the square root of x, basically, x to 1/2. When x approaches 0, this is 0. 0 times -2 is 0. Don't jump up and down, it's not done. At this point, I copy the beginning. I copy the beginning. And I copy the end. So in step 4, copy limit as x approaches 0 from the right natural log y, and the end. All this is gibberish. I don't need it anymore. Okay. Some time ago, under continuity, I talked about some theorem I like to call it swapping of operators. So here's an example. You will remember this, I'm sure. Limit as x approaches a from the square root of a function. I swap the operators. The square root is applied first. The limit is applied next. I'm going to swap or change the order. I will put the square root outside and the limit inside. I swapped the operator. The operator called limit, which is tendency or trend, and the operator that takes the square root. I put them in reversed order. I swapped the operators. This is what we need to do next. So after I copy the beginning and the end, because these are continuous functions, I'm going to swap the operators. Exactly as with this example. So I'm going to write natural log of the limit of y is 0. So in step 5, natural log of the limit as x approaches 0 from the right of y is 0. And finally, I'm asking you this question. Natural log of what is 0? There is only one number whose natural log is 0. Or you can say, I don't want to do that. If you don't want to do that, that's fine too. Just change it into the equivalent exponential equation. Or you think natural log of blah is 0. Or you change it into an exponential equation, whichever you prefer. So what does the limit equal to? And remember, y was
0.
no, because e to 0 is not 0, and I cannot plug in 0 in natural. Yes, indeed. This cannot be anything else but 1. How come? Because natural log 1 is 0. So therefore, 3 pages ago, the limit of this function is 1. And you could have said, I'm not a believer. 0 raised to 0 is 1 by accident. Trust me, by accident. Any questions? Okay, let's quickly summarize before we choose another. Whenever I encounter any of the powers, I label the function, apply natural log like I always do in this case. I apply the limit. I struggle. I get this limit. In the next step, I copy the beginning and I copy the end. Here, I swap the operators. The natural log goes outside. The limit of the function goes inside. And I say e raised to 0 is this. But e raised to 0 is 1. And no, 0 raised to 0 is not 1. It just happened by accident. 0 raised to 0 is a complicated 3-page situation. 2.5. Very good pick. It was a very good one. Okay, this is the last thing we need to do, so let's practice other powers. And that's the last thing we need to do in 4.4, and then I'd like to go back to 4.2 that I skipped. Which other powers you want to work on? We need to work on at least one more. I know they're long, but we still need to work on at least one more. Can I choose 59, or you want to choose something else? Go ahead.
59 is fine.
Okay, so let's do 59. What is it? So limit x approaches 0, 1 minus 2x raised to 1 over x. Okay. So please walk me through the steps. So let's analyze the steps. It's easier if we repeat them in class, so it's easier for you later. And this is the end of 4.4. So
we're going to name the function.
not yet. We have to see first. Here we have to plug it in. Here we have to plug it in. Where is 1 minus 2x going?
To 1.
Excellent. Where is 1 over x as x approaches 0? It should be better 0 from the right, because limit as x approaches 0 from either side is d and e. So I'm going to take the liberty and put plus here. Maybe it was there and I didn't copy it. They didn't put it in. So as x approaches 0 from the right, where is this going?
You'd have 0 in the denominator.
Remember the graph. Think about the graph.
Oh, just the I'm just thinking of power with it. Never mind.
Think about the graph of 1 over x. The graph of 1 over x is this. We have to remember this. This is very powerful if we remember these graphs.
So it's, oh, from the right,
Yes,
it would be positive infinity.
good. So we have 1 to infinity. This is definitely an indeterminate case. It's one of these three. As you see, 1 to infinity. So we looked at 0 raised to 0, and now this is 1 to infinity. Good. Now the steps. So let's review the steps. First step, what do we do? Step number 2. In step number 2, we have to
Apply log.
excellent. Good. In step number 3,
Apply the limit to both sides.
yes. Limit as x approaches 0 from the right from natural log y equals the limit as x approaches 0 from the right from, and I can write this condensed, natural log of 1 minus 2x divided by x. Now I'm struggling with this, so to speak. Not really. So let's plug it in and find what it is. Preliminary, of course. What is it? Anyone, please?
Zero over zero.
Of course. Beautiful. Limit as x approaches 0 from the right. Can anyone differentiate the top and differentiate the denominator? Let's differentiate the denominator first. That's the easy part.
1.
Perfect. Now let's differentiate natural log of 1 minus 2x.
1 over 1 minus 2x
Times
times
the inner function prime.
2,
Careful.
-2.
Yes. Good. Now we plug in 0. What is the answer?
Would be 1
Negative
over
2 over 1.
We have a negative 2 over 1. Negative 2. In step 4, what do we do in step 4? Because when x approaches 0, this is 0. And I have negative 2 times 1 over 1, 1. Step 4.
Copy limit and
Yes, exactly. I copy the beginning and I copy the end. The rest is not important anymore. It was, but not anymore. So limit as x approaches 0 from the right from natural log y equals negative 2. What do I do in step 5?
swap the operators.
That's it. the equivalent equation, exponential equation of this. How do I write it?
E to the power of -2 equals the limit of as x approaches 0 from the right.
From y. And that is y. I'm going to copy it already. So the final answer is that the limit that we were looking for is 1 over e squared. So as you see, this was more straightforward and faster. Why? Because we already had a more evolving situation, and this was easier. Why was this easier? Because the limit was obtained not with 3 pages, but in 2 rows. So then I copied the beginning and the end. I swapped the limit operator, and I applied algebra to determine this limit. E to -2 equals the limit. So then the limit from y, which was 1 minus 2x to 1 over x, equals e to -2, which changes into 1 over e squared. Did we have enough limits? You tell me. If we did, then I have to go back to section 4.2. We can continue with 4.5 and look at a graph. So now this, what did we just do here? These limits are helping us in graphing. So if you remember, we got stuck a little bit here because I didn't want to jump into 4.4. As you see, we had to build these limits based on their difficulty level, one by one, step by step. So I didn't want to jump into this. But this was an important situation because we needed this limit. So the reason why we studied 4.4 is basically for graphing. And of course, for knowing those limits, but also for graphing.